Good evening. We're here this evening with Tom Campbell, author of My Big Toe. Tom, pleasure to have you here this evening.
Thank you, Donna. Glad to be here.
Current consciousness research seems to struggle with the hard problem. What is this hard problem and why is it so hard?
It's a good question. Hard problem of consciousness is showing how, and when I say how, I mean scientifically, showing how inanimate particles can go together in some configuration to produce consciousness. How can you assemble groups of particles and assemble something that becomes conscious? That's the hard problem. And consciousness researchers have been working on this hard problem for many decades. And there are lots of theories about how it might work out, how you might solve that hard problem, but none of them have got past the point of, I'd say, wild conjecture. They have a conjecture, but there's really no scientific information to connect those dots. For instance, there's an idea that microtubules in the brain may be in specific quantum states or be in changeable quantum states that then might be able to explain some of the unusual behavior in consciousness. And basically what they've done is they've looked at quantum mechanics and said the quantum world is full of weirdness and strange things that we don't understand, things that are non-local, okay? And consciousness is kind of a strange thing that we don't understand and is non-local. Therefore, what we need to do is find a way to connect those two. So we think, our theory will be that quantum effects, entanglement effects, are the source of consciousness, because we have consciousness that does strange non-local things, and quantum mechanics and entanglement is something that does strange non-local things. Therefore, we want to marry those two. Well, that's not exactly a theory. That's what I would call wild conjecture. Just recently, some sort of quantum and microtubules was shown to be a possibility, and it's like, okay, we've solved the problem. But of course, they haven't solved any problem at all. The problem of showing how science takes you from, quantum states to consciousness is like a huge gap. All they've done is they've had some wild conjecture, and one of the components of their conjecture has turned up. But that is not, that doesn't make any links to consciousness. And the reason the hard problem is so hard is because consciousness has nothing to do with physical process. You see, the hard problem is, how do we take physical process? How do we take a bunch of physical particles and create consciousness with them? Well, consciousness is not made of physical particles. Consciousness does not derive itself from physical consciousness. So that's why it's such a hard problem. Why can't I flap my arms and fly? You see, that's a hard problem. Well, it's because that's just, that won't work, and this won't work. You'll never be able to derive consciousness from physical phenomena, because that's not the way it's done. That's not the way it works. There's other hard problems that are very much the same, in the same boat as consciousness. In fact, physics has a whole list of hard problems. And all of their hard problems are all of the fundamental things of physics. Okay? In physics, mass is a hard problem. And by that I mean, what is mass? Where does it come from? Physicists have no idea about that. Well, they've just done this Higgs boson, and that was supposed to help, but that's more wild conjecture. Where does mass really come from? Don't know. Charge. Where does charge come from? What is it? Where does it come from? Nobody knows. Space. Where does space come from? What is it? Where does spin come from? Now they do realize that spin isn't really anything spinning, that's just a metaphor, but they won't admit that, the mass and charge and so on, that they're metaphors too. They won't admit that. They will that spin. And time. Where does time come from? What's the source of time? What's the source of spin and space and charge and mass and consciousness? So we see in this group, every one of them is a fundamental attribute of our reality. Okay? All of them are fundamental. And none of them are understood. So what we do in physics is we don't know where mass and charge and time and that stuff comes from, but we know that if we just start there, start with mass, we don't start with where it comes from, we just start that we have it. Here it is. Same with charge, same with space. Then we can manipulate those things. And all of physics is basically how do these fundamental things interact? That's what physics is all about. So, we have space and time. Well, if you change your location space as a function of time, that's called speed or velocity. You see, if it has direction, it's velocity. And then you can change velocity as a function of time, which is space as a function of time as a function of time, and you get acceleration. And then you take this this attribute mass and multiply it times the acceleration, and you've got F equals ma, which is one of Newton's equations, and you end up with force. So you see force, motion, gravity, acceleration, all your physics things. You get by moving charge with a function of time. You get current. You get electricity. Then by moving charge, you also generate electric fields and magnetic fields. So it's taking all these things and seeing how they interrelate with each other is what generates our physics. But what these things are themselves, there's no clue. That's all hard problems. So physics has a whole list of hard problems. And oddly enough, they're all the very fundamental basic things of physics. Our hard problems aren't big equations. They're simple things. What is mass? What is charge? What is consciousness? And all of these fundamentals are misunderstood or not understood at all. And we work with them, but don't really understand them. So that's kind of interesting. Most people wouldn't consider that mass and charge and space and time and spin were all hard problems in physics. Well, that's the stuff everybody takes baby physics. You take physics in high school, you deal with all these things, and they're just a given. They're just there. But we don't think about, well, where'd they come from? What are they? And we can define them in terms of each other. We can say, oh, I know what mass is. It's force divided by acceleration. Well, we can define them relatively in terms of each other, but we don't know what they are. Now, an interesting thing about hard problems. There have been hard problems in history. And we can look at several of these. A couple that everybody knows about is the spherical Earth, the round Earth rather than the flat Earth. That was a hard problem. The reason it was such a hard problem, though they had lots of evidence, they could look at the moon and see the shadow of the Earth on the moon and see that it was a circle, right? It was rounded. And they could watch the ships sail out at sea and see that the ships kind of disappeared like they were sinking in the water. First you'd see the whole ship, then just the top 2/3, then the top half, then the top third, and the last thing you saw of that ship as it sailed straight away was the tip of the mast where the flag was flying, and then it too fell beneath the water. Well, that's because the ship was going over the curvature of the Earth and disappearing, as it went over the curvature and down the other side. It just made the ship look like it was sinking in the water. And when the ship comes back in, it does the same thing. The first thing you see is the top of the mast. and then it's like the ship rises up out of the water. So there are lots of hints about it being not flat. But it didn't make any sense, because if it wasn't flat, if it was round, all the water would run off the sides. That's what happens if you pour water on a ball, right? It all rolls off the sides. So the fact even that we had oceans told you that it couldn't be round. And what would be on that other side? Everything would fall off. If you got too close to the edge, you'd fall off the earth. And there couldn't be people or land or things, at least not things that were connected to the earth, because they'd all fall off. That's what happens if you have a ball and you put something on the bottom of it and let it go, it falls off. So it was a hard problem because they didn't understand the concept of gravity. They didn't understand there was such a thing as gravity, or how gravity worked. I guess they did know there was gravity in the sense they knew that you could drop something and it would fall, but they didn't understand how that worked. They didn't see gravity in a big picture. They only saw it in a local picture. Well, what that is a paradigm shift. They had a little picture paradigm. They needed a bigger picture paradigm. And as soon as they got the bigger picture paradigm, there it was. It's like, oh yeah, of course. Should have known that. That makes sense, you see. And then it went from a hard problem to a trivial problem. It was just easy. Well, we had the same thing with the Earth being the center of the universe. And that was an obvious thing. Earth had to be the center of the universe because everything went around the Earth. Just go out and look. The sun comes up in the east, it goes down in the west, and comes back up in the east, it goes down in the west. It's going around the Earth. Same with the stars. They all, rise and set, just like the sun and the moon. Everything goes around the Earth. Any child could see that. If it goes around the Earth, then the Earth must be in the center. You see, perfectly obvious. So it was a hard problem. It took a long time for people to get it that that wasn't the case, that the Earth was going around the sun and rotating on its axis at the same time with a little tilt in its axis. And then suddenly we understood things like not only day and night, but we understood things like season, and why the seasons reoccur. Why you go through spring, summer, fall, and winter, and then back through spring. We understood the cyclical nature of things. So it's the same thing. The point is, the big picture point here to take out is that when you have a hard problem that's fundamental, and I don't mean a hard problem in a calculation or a hard problem at a much higher level, but at the very bottom level of understanding, when you have a hard problem, that means you have a paradigm problem. That's what it means. We don't understand consciousness, mass, charge, spin, time, space, because we have a paradigm problem. That's the way it always has been. All the hard problems in the past, fundamental problems, have been paradigm problems. So now we have all these hard problems, and we expect it to be something else than a paradigm problem? That's not what history shows us. It shows us that it's a problem in approach. It's a problem in the way you're looking at the problem. Okay. Now, one of the interesting things about a virtual reality is that there's a lot of things in a virtual reality that just are. And the virtual reality itself just starts out of nothing. Okay? Think of World of Warcraft. There was no world with elves running around in it. There was no World of Warcraft world until the run button was punched at the server. As soon as the run button was pushed, there it was. World of Warcraft world just popped out. There it was. The whole world was there. You see, it had all the elves and the barbarians and the rivers and the streams and the rocks and the trees, and everything in that world just suddenly occurred without any cause. Without any cause, if your vision is from inside that world. If you're outside that world, outside that virtual reality, the cause is easy. The cause is in the computer. The cause is in the programming. The cause is when the run button hits the cause. But if you're inside that world, and you traced your history back, you're an elf now. World of Warcraft has been running for a long time, and you're trying to figure out what the origin was. You'll go back to a time when it just seemed to poof out of nothing and exist. Well, that's the way our world seems to have occurred, in a Big Bang. Before the Big Bang, there was nothing because there was no physical universe. And if the scientists are right, and everything has to be causally related to a physical universe, all causes, all reality is physical and comes from the physical universe. Well, before there was a physical universe, where did this little ball of high temperature, high pressure plasma come from that then went bang? There was no universe, so it wasn't part of our physical universe. What was it? Well, we don't know. We just know that if you compute a plasma ball at a time, and suddenly the clock starts. You start at t equals 0, and suddenly the clock starts ticking. It starts expanding and cooling, and you end up with our universe. You end up with planets and suns, and then a planet like ours, and then people and so on. But it's impossible to say where that came from because it couldn't come from physical universe. It had to come from outside, and anything outside of the physical by definition is non-physical. So our beginning started from something non-physical. Well, we don't want to go there for scientists. That doesn't sound right. So we just say we kind of don't talk about that very much, of how that plasma got there when there was no universe. Well, that's a case where it just poof started out of nothing. It just seems to have started expanding. Okay, well I call that the big digital bang, where when the run button was pressed, the initial conditions and a rule set allowed, started with that plasma in the ball. That was the initial conditions, and there was a rule set about energy exchanges and how things could change. And when the button was pushed, the simulation started and things started to change, and that was t equals 0. And time's been counting ever since. So you see, that's the mark of a virtual reality, is that it just starts. From the viewpoint of the characters inside the reality, it just starts. Okay, from outside the reality, they see the causality. The run button was pushed. Inside the reality, it just seems to start out of nothing. It's the same with the mass and charge and spin and space and time. In a virtual reality, these things are just defined in the rule set. They just are. They don't have to come from anywhere. They're just definitions in the rule set about how things interact. You see, part of the rule set. So they don't have a prior causal, physical causal trail or causal chain. They don't have that. They're just defined and are part of the rule set. So one doesn't, expect a causality. So when you're looking, what causes time? What caused mass? What caused charge? It's a hard problem because there's no answer. Nothing caused those things. Just like what caused the Big Bang. The cause is outside of this physical reality. So that's the nature of a virtual reality. So the hard problems are that we don't have a big enough picture. We're looking at it with a little picture. When we say everything must have physical causality, then we've painted ourselves in a picture too small to understand where mass and charge and space and time come from. If you look at a virtual reality, then, well, it's easy. It's part of the rule set. That's the way the simulations run. If it's a dynamic simulation, you have to have a time loop that drives it. Every delta t, you calculate, the next set of positions, the next set of things that are happening as a function of time. So that's where these things come from, and partially our scientists get it. I've heard physicists in conversation say things like, "Oh, we don't think of electron as a little chunk of mass with charge anymore. We used to think that, but that just doesn't work in the experiments. That's not what we're getting. What we find an electron is a point with the attributes of charge and the attributes of mass. That's far different than a little chunk of mass with a charge. It's a point with attributes. Well, if you were going to simulate an electron in a computer, what would it be? It would be a point with the attributes of mass and the attributes of charge. So what they're seeing, what their experiments are telling them, is that it's virtual, you see. But they just say, oh, you know, it's strange physics.
Well, is that a step forward?
Yes, it is a step forward. Yeah,
scientists are seeing.
Exactly. What's going on is that the research they're doing, the experiments they're doing, are pushing them to this idea that our reality is information-based. It's just information. It's like a simulation. It's a point with attributes. Okay? These things are calculated. And lots of experiments now are pushing science in that way. But scientists are very stubborn about giving up that physical causal chain. So they will say, yeah, it seems to be just information. And they may even say, yeah, reality seems like it's just informational. And we'll even call that a virtual reality. But to take the logic any further, they don't want to go there. That's about as far as they will go. You have to have one more, I mean, there's a simple logical step that physicists will take because they have to. It's logical, and that is, if it happens and it's not out of this physical universe, like the Big Bang, it had to help it elsewhere, well then the source has to be elsewhere. As Fredkin said, it has to be in other, not here. And by here he meant not this physical universe, because a simulation cannot compute itself. It has to be computed somewhere else. Now this is a trivial piece of logic, and if you think about the elf cannot have the server in its reality. In other words, the server that's creating World of Warcraft has to exist outside of the World of Warcraft universe. The World of Warcraft universe is all the trees, rocks, elves, you know, people, all the map, if you will, the mountains, the streams. All of that is the World of Warcraft. That's that world, that universe, and the server has to be outside of that. The server couldn't be inside. In other words, the elves couldn't have made the server because they're computed by the server. You see, very simple little logic. So the source, if you will, has to be outside of. The source of the virtual reality cannot exist inside the virtual reality that was made by that source, because the virtual reality cannot compute itself. So that says that our source, the source of the Big Bang, the source of mass, the source of all these things, you know, why do we have those? The source has to be outside of this virtual reality. Okay? Consciousness has to be outside of this virtual reality, just like the mass and space and time. Well, consciousness then is not a part of this physical reality. So all those scientists who are trying to say, consciousness is somehow made out of little particles, they're trying to make consciousness have a physical basis. Something physical had to create consciousness. It's not like that. Consciousness exists outside, must exist outside of this reality. Then all the pieces tend to fit. You see, consciousness is an information system. What is your consciousness? It's your awareness and your ability to operate upon that awareness. Okay, it's information. Take take all your senses. What your senses do is gather information. They gather light, they gather acoustic waves, that's sound, they gather pressure, it's touch, they get, smell, molecules that react to the various chemicals and odors, olfactory system. All of these things are just sensors that collect data, collect information. And we interpret that information to be this physical world that we see. So already we see our physical world is simply described by information. So that's our consciousness. Everything we're conscious of is just information we collect through our senses. So consciousness is an information system. A virtual reality is an information system. Consciousness cannot be, the origin, the fundamentals of consciousness have to be outside of this physical reality. And how it turns out is that consciousness is the computer. Consciousness is the information system that computes our virtual reality. Okay, so all of that makes perfectly good sense. We have an information system that we know is our consciousness. It has to be outside the physical system. It can't be because of microtubules anywhere or any other kind of scheme of physical matter and physical things. It's not that. And that consciousness being an information system and something that does do analysis, our consciousness does analysis, it thinks, it judges, it compares, it has all those functions that a information system needs to have. So consciousness is the computer. Consciousness is our server, you see. But now, your consciousness and my consciousness isn't the whole server. So we obviously are pieces. We're subsets of a larger consciousness of which we all belong. So you see how this all ties in together. So what are these hard problems? Well, the hard problems exist because of a small picture misunderstanding of the nature of reality. Not even misunderstanding, just a lack of understanding of the nature of reality. That's why we have the hard problems. It's a paradigm problem. It's a perspective problem. It's a point of view problem.
Your example of the past paradigms, which are so obvious now,
right,
show that scientists need to look further. Scientists are on the verge of what you've already discovered and derived in your My Big Toe, but surely, to me, that the examples you've given are, if they relate those past examples to how stuck in a paradigm they were before, they can see that being on the verge of this discovery that consciousness is outside of this system, it should be coming forthwith.
Yeah. If there's, it's like this. If there's a virtual reality, if our reality is computational and virtual, as scientists are beginning to understand, then consciousness can't come from within it. It has to come from without it. Okay, that's just the way it is. You can't, like I say, a simulation, a virtual reality cannot compute itself. Something's computing it. And what is computing it has to be some sort of information system. Right? That's what information systems do. They compute things. So there has to be this big information system outside of our reality in order for us to have this reality. Well, and what are we? We are, what is our consciousness? Our consciousness is about information. It's all about the information we collect from our senses and how we interpret it. Take away all the senses and we would be nothing but awareness, in a black void. Feel nothing, see nothing, hear nothing, smell nothing, and we'd just be floating consciousness in a void if we took away our senses. So we wouldn't have this reality. This reality would disappear. So this reality is data we collect. So we must have a larger information system outside, and here we are, basically information-based awareness, information-based, our consciousness. Well, it's not hard to take the leap that says that consciousness is the computer and we are pieces of that consciousness. Now, that is kind of a small, leap to take. But if we make that assumption, then all sorts of other problems fall out. You know, we can derive things that we actually see and witness here and have experiments tell us that it works. So that's the nature of the hard problem. The reason it's so hard is that they can't get to the answer under the paradigms that they're working under. And as long as they try to find a physical cause for consciousness, they will be frustrated. And it will always be a hard problem. They have to take the next step, which is to understand that consciousness exists from the larger consciousness system, the larger information system that is running this virtual reality. So that will come. Once this virtual reality is more and more impossible to ignore, science will get there. And when they do, somebody will say, yeah, okay, it's a virtual reality, but where is it computed? By what is it computed? And then they'll have to answer other, because it is irrational to say it's computed. It computes itself. And once you have other, then you're basically all the way to the point. Now we are in a virtual reality computed by an information system. And we just happen to be, our consciousness happens to be an information system. So that seems to make sense. So that's kind of the thing about the hard problem. All fundamental problems turn out to be due to erroneous paradigms. They just have the wrong idea. And once you see it, then it's trivial. Everything's so very simple. It's not a problem. Another hard problem, of course, is the double slit experiment and entanglement. These are hard problems. That's why the theorists in quantum mechanics throw up their hands and say, "Oh, nobody will ever understand that. That's just impossible." Why the double slit acts the way it does is a hard problem, and they'll never understand it until they understand the bigger picture. And once they understand this is a virtual reality, and that it's a probabilistic reality, then how the double slit works and why entanglement works and why quantum mechanics reacts and acts the way it does, why particles should best be described by probability distributions is trivial. It's simple. This is a probabilistic virtual reality. It's not a deterministic virtual reality. It's a probabilistic virtual reality. Okay.
Your understanding has allowed you to derive a big theory of everything, which means you've come from outside of this physical reality.
Yes.
Stephen Hawking has been quoted as saying he wishes there was one simple equation that would bridge quantum mechanics and relativity, one simple equation that would give you the unified field theory. And you've done this because of your big picture.
Basically. Now, mostly I don't express it in an equation, but you could. And the equation, he talks about simple. The simplest equation of all, the very ground state and simplest of all equations is a simple identity. And that is that reality equals information. See, that's as simple as it gets. That's not a complex equation. But that tells it all. Reality equals information. It's virtual. So that's why we have hard problems. That's why physicists throw up their hands at these fundamental things. So we know all how these things interact. We know how mass and charge and space and time, these things all interact with each other, and that's what we physicists do, is work out all those interactions. We have Maxwell's equations, basically 4 basic equations with a couple ancillary equations, and they tell you everything you want to know about macroelectrodynamics, electromagnetism. Just 4 little simple equations. They're not even big equations. Well, they're partial differential equations, so they're complicated, I guess, but they're not all that big. Can be written on just a little bit of paper, and that's elegant. And you find that nature being evolution, the products of evolution tend to be elegant. Truth, natural truth, tends to be elegant and simple. The reason is that our reality has evolved. And evolution basically searches for the most efficient solution. That's what it is. If evolution has found a solution and it's not efficient, eventually it will change and evolve to be an efficient solution. And if the environment continues to change, then what's in that environment will continue to change to keep trying to become efficient. So evolution creates efficient processes. So when we find something that is simple and elegant, we've more likely to find truth. When we find something in science that's hugely complicated, we're more likely to not have found truth. So all of these very complicated theories about how inanimate particles can create consciousness, they're not elegant, they're not simple, they're not straightforward, and of course they don't work. They also don't make any sense. And they never will, because that's just wrong-headed. You see, it just it can't work because it's wrong. No more than I can flap my arms and fly. It just isn't going to happen. And it's not going to happen that somebody is one day going to find out how inanimate particles create consciousness, because they don't. Particles do not create consciousness. Consciousness creates the virtual reality that births the particles. You see? So that's the hard problem. Kind of a little history of, and the two I gave of the flat Earth and the Earth being the center of the universe. That's just two. If you go through history and look for fundamental things that were just hard problems, not understood, you will find that all of them, it wasn't that there was just a piece of data that was missing. All of them, the problem was the wrong way of looking at the problem. They were looking at the problem in an old way, in a way that had worked on other things but wasn't working for this one. And it's that failed paradigm that is the problem. Somehow physicists don't understand that all of their basic fundamental quantities are all hard problems. I mean, if there's anything that tells you you've got the wrong paradigm, it's that. That's just screaming, in the face. You've got the wrong paradigm. All of these basic things in your science are hard problems. You've got the wrong paradigm. You're not looking at it from the right viewpoint. So that's the case. Now, virtual reality is the right viewpoint. That does, solve a lot of these problems. And in virtual reality, of course, the logic says that consciousness, being the information system that is the creator of this virtual reality, is non-physical. It has to be non-physical. It has to be outside the physical system, outside the physical universe. So now our universe evolved from that rule set and that set of initial conditions. And as it evolved, it eventually evolved us. See, so here we are, and it's just so obvious, I guess, that the hard problem of consciousness is only hard because they're looking at it from the wrong direction, and there is no solution from the direction that they feel they must come from. So that's my take about the hard problem, what it is, why it's like that, and it'll stay like that, and it'll remain to be a hard problem along with mass and charge and space and time. People will not understand the origins of these things until they see a bigger picture. As long as they're stuck in the little picture with erroneous beliefs, which is beliefs in that's what we'll call their paradigm is basically made up of erroneous beliefs. They will never understand the double slit experiment. They will never understand why quantum mechanics works the way it does, why particles should be probability distributions. They'll never understand consciousness, mass, time, space, any of those things. Will always be mysteries, because you can't get to there from here. You can't get to there with the beliefs that scientists have today about this being a objective physical reality. And that's all the reality there is this objective physical reality. With that belief, then none of these other things will ever be understood.
I think that's a very powerful statement, and those past examples illustrate that very well.